All right, now I'm going to look at my dissection of the 10 active lesson plan and explain why I evaluated myself the way that I did. So here we have the 10 active lesson plan activity that we did. My original lesson plan was designed for 3 days. It was specifically supposed to focus on incorporating elements of UDL into my instruction. So the lesson plan is definitely centered around that, and technology was not very much of a consideration, if it was one at all. I analyzed, I believe, the first day of my lesson plan on this lesson plan breakdown activity. So the idea was that students are learning to discuss functions in their everyday lives, right? So the idea is maybe like a vending machine could be a model of a function because you put something in, you put some money in, you press the buttons, and then you get, a specific thing back out. So that was the idea, to like have students think about like, is there anything in our lives that models a function? And then from there work towards the formal definition. So I took it from, let's see here, from this body of lesson section. This inquiry based was going to be an informal discussion. There was no technology planned to be involved with this. I figured, maybe just a whiteboard, small discussion groups. And then the students would think, pair, share, and discuss, among themselves, the idea of a function. We would have talked about functions as a group together and been like, hey, a vending machine, a printer, Face ID. These are all examples of something where you put one input in, you get one input out. And so we would have students think about, what are the similarities, what are the differences between these things that we looked at? And then we would have another inquiry-based activity where we would, talk about the similarities and differences that students observed, and ultimately work towards saying like, hey, a function is something where there is one input mapped to one specific output, this one-to-one going on. And here is my first instance of technology. It's showing the students a graph that I constructed myself. So this is very much students passively receiving information from technology. They're not given an opportunity to engage with the graph themselves, manipulate variables, and see how things change. So that is the first area where I had technology. And because the students are passively receiving information, I rated myself with yellow, which is entry level. And then the next activity would be, leading a discussion about what is the domain and range of the function. And then finally, the students would do some collaborative group work, and this would be an opportunity for them to engage with technology. So I constructed 3 problems that they would work on. These lesson plans are awful. They're not readable at all. So here's one where students are again provided with a graph, and then they need to engage with it to describe, the domain and range, where the function is defined, where it's not, continuous, discrete, etc. The only place students get a chance to actively engage with technology themselves is on part 3, where they're instructed to graph the functions themselves. So that could be with a graphing calculator. It could be on pen and paper. It could be with Desmos, incorporating that student choice. But ultimately, that's using a technology tool in a standard, well-defined way that students are likely familiar with. In an Algebra 1 course, they've probably graphed something before, and likely with technology because of, COVID, etc. So, because students are actually working by themselves here, by themselves being with a small group, I determined that was adoption. I tell them what they're supposed to be graphing. I'm monitoring their behavior. We're using Desmos in a standard way. So those were the only 2 instances of technology in my lesson. So overall, not very techy. And I definitely think there's room for exploration, especially with these graphs here. So we talked about some of the UDL. You're given choice over how to graph those in the collaborative groups. I'm giving them multiple representations of functions. I'm using words, an equation, a graph, a picture. And then at the end, there's an exit ticket with sentence stems to really help them out there. Also, I imagine like in a classroom, I would have a word wall with math vocabulary, something of that nature to really help get the language down for students. Yeah, so looking at this lesson plan, I think that technology could be used in a way where students, maybe instead of doing this, like what is a function in the real world, we can play around in Desmos and see what happens whenever students, manipulate variables. So maybe that means we start with like 3 equations, like a horizontal line, y equals 3, for example, a vertical line, x equals 1, and then the diagonal line, y equals x. And I have students manipulate these, add, subtract, multiply, do whatever they want and see how the function changes. I think that would probably be more instructive than them, trying to think about things that may or may not be relevant, like a vending machine and a DVD player. It also allows them to use technology that I think is super helpful and will continue to be used throughout the school year. In a low stakes environment, it allows them to, get comfortable with some of the features of Desmos without sitting down and doing an actual, here's how you use Desmos. Yeah, so I definitely think there's room for improvement with this lesson. I could see this lesson definitely moving to the adaption level. If I thought a little more about other graphing software, about other ways that we can model functions using technology, potentially could move to infusion, but very easily adaption. Yeah.